Okay, Assalamualaikum and hello to everyone. So in this video, we will discuss for one of the question, okay, for chapter 2 in the tutorial section. Okay, so this is the A portion of the question, which is divided into two sections. So for the first section, subjective question asking us to define three types of thermodynamic processes. So I believe that this can be answered by referring to the notes. Okay, so please refer to the notes to get the definition for the three thermodynamic processes. Okay, for number 2, okay, so we can read the question, and when we read the question, we know that there is a piston cylinder device. Okay, the mass is 2 kilograms, the substance is a refrigerant R134A. Okay, the initial states are pressure 1.4 megapascal, phase is given as saturated vapor. Okay, and then it undergoes an isobaric condensation process. So isobaric means constant pressure. Condensation process here means a cooling process. Okay, condensation is the process when vapor changes into liquid. Okay, where heat is removed from the substance in order for it to change phases from vapor form into liquid form. So until the last drop of the refrigerant becomes a liquid. So from saturated vapor, the substance will change its phase until it becomes saturated liquid. Okay, so step 1, we will try to draw the schematic diagram. So we have a piston cylinder. Okay, for state 1. So what is known is the pressure 1.4 megapascal or 1400 kilopascal, and also the phase set vapor. Okay, and then we have a process, so there will be a state 2. The piston will be slightly lower because of the cooling process. So this is known as state 2. Constant pressure process, isobaric, and the phase is saturated liquid. Okay, because why? Because until it becomes a liquid, not a mixture, liquid. Okay, so saturated liquid. So connect both states by the process. Okay, so it's an isobaric cooling process. Okay, so for step 2, okay, we write whatever equation which we require. So it wants to count the boundary work. So the boundary work, okay, the boundary work for an isobaric process is the pressure multiplied with the change in volume. Okay, so this is, if I can write it here, sorry, 1 to 2 equals to P multiplied with the change in volume, or in specific volume form, mass times the pressure multiplied with the specific volume at state 2 minus state 1. So when we find the properties, make sure we read for the properties specific volume state 2 and also state 1. So for step 3, now we try to find the properties. So for state 1, okay, what is known is pressure 1.4 megapascal or 1400 kilopascal, and also the phase set vapor. So using table A12 at 1400 kilopascal, we will read for, since set vapor, saturated vapor, V1 is equivalent to Vg. Okay, so the value for Vg from the table is 0.014107 meter cubes per kilogram. Okay, that is all for state 1. Then we proceed with state 2. Okay, pressure is same, so 1400 kilopascal or 1.4 mega. Phase now is saturated liquid. Okay, so for saturated liquid, specific volume at state 2 is equivalent to Vf. So here the value is 0.0009166. Okay, 166 in the unit meter cubes per kilogram. Okay, so that is all for step 3. So for step 4, okay, so work 1, 2 equals to mass multiply the pressure change with specific volume 2 minus specific volume 1. So the value 2 kilogram for mass, pressure is 1400 kilopascal, specific volume 2 is 0.0009166 minus 0.014107. Okay, so by calculating the values, all right, make sure you press correctly the calculator. Okay, sorry for the delay. Okay, so we should get negative, right, negative 36.93 kilojoules. Okay, so negative here means work is done. Okay, work is done, so it's work is done to the system. Okay, that's why the piston is moving downwards, because we are putting in work. Okay, work into the system. Okay, so that is for the first portion of the question.